Mr. Right here, and welcome to this film in which I will walk you through my solutions to 12 IGCSE Maths questions on transforming graphs. You can download the questions by clicking the link in the description, and then you could tackle the questions and then watch the film, or you can work on the questions as you watch the film and work alongside me. You'll find the questions get harder as you work your way through them. If you're unsure how to tackle these questions, you might like to watch my Golden Rules video first. You can find the link for that on the screen now. If you find the film useful, please do tell me so in the comments. Please do click like. If you've got a question, then leave it in the comments, and of course I'll respond, or leave me a comment anyway. How did you find the film, and what are you working on next as you prepare for your Edexcel IGCSE Maths? Right. Let's get on with the maths. Question 1. The diagram shows a sketch of the curve y equals f of x. There is only one maximum point, and the coordinates of this maximum point are 5, 7. Write down the coordinates of the maximum point on the curve with the equation. Right, in part 1 here, the change is inside the bracket. It's going to be a horizontal change the wrong way. It's going to be a change to the x-coordinate in the negative direction. I'm going to minus 9 from the x-coordinate. It was a 5, so now it's going to be minus 4, 7. Part 2. Right, the change is outside of the bracket. It's going to be a change to the y-coordinate, and it's going to be a change in the direction I'd expect. So I'm going to add 3 to the y-coordinate. The x-coordinate remains the same, and the y-coordinate is 3 more. Question 2. A curve has equation y equals f of x. There is only one turning point, and the coordinates of the turning point is 6, 5. Write down the coordinates of the turning point on the curve with this equation. Well, the change is inside the bracket. So it's going to be a change to the x-coordinates, and it's going to be a change the wrong way. So I'm going to add 4 to the x-coordinates. So no longer will it be 6, but the x-coordinate will be 10, and the y-coordinate will remain the same. Right, part B. Again, it's a change inside the brackets. So it's going to be a change to the x-coordinate, and it's going to be the wrong way. So it's not going to be multiplying the x-coordinate by 3. It's going to be dividing the x-coordinate by 3. So the x-coordinate won't be 6 anymore. It will be 2, and the y-coordinate will remain unchanged. Question 3. The diagram shows a sketch of part of the curve with equation y equals f of x. There's one maximum point at 4, 6. Write down the coordinates of the maximum points of these curves. Right, well, the first one, the change is in the bracket. So it's going to be a change to the x-coordinates. It's going to go the wrong way. So I'm going to subtract 4 from the x-coordinate. So no longer will it be 4, 6. It will now be 0, 6. The next one is a change inside the bracket. It's going to be a change to the x-coordinate. It's going to go the wrong way. So I'm not going to be multiplying the x-coordinate by 2. I'm going to be dividing it by 2. So no longer will it be 4, 6. It will now be 2, 6. Right, moving on. The equation of a curve C is given to us here. The curve C is transformed to a curve S under the translation 4, 6. So the curve moves 4 units to the right, and it moves 6 units up. Find an equation of the new curve. You do not need to simplify the equation. Well, if the old curve has been moved 4 units to the right, that's a change in the x direction. So it's no longer going to be y equals f of x. It's now going to be y equals f of x. Now it's moved in the x direction, so the change is in the bracket. It's moved positive 4, so it will require an x minus 4 in the bracket. Now, what about this moving the curve up by 6. Well, that's a change in the y direction, so the change will happen outside the bracket, the correct way. So what I'm dealing with now is instead of f of x, I'm dealing with f of x minus 4 plus 6. So instead of y equals x squared plus 3x plus 4, if that's my function of x, I'm now going to have not a function of x anymore, but a function of x minus 4. So I'm going to have x minus 4 squared plus 3 lots of x minus 4 plus 4 at the end, and then plus 6. So that is the equation of S, and it tells me I do not need to simplify the equation, so I can simply leave my answer like that. Question 4. The graph of y equals f of x is shown on the grid. On the grid, sketch the graph of y equals f of a half of x. Well, the change is in the bracket, so it's going to be a change in the x direction. It's going to be a change to the x coordinates. How are the x coordinates going to change? Well, they're not going to be multiplied by a half. They're going to be divided by a half, or doubled. So the x coordinates are going to double. So let's look at each point, or several points, and see what happens if I double the x coordinate. Let's start with this one here. This point has got an x coordinate of 3, so now it will have an x coordinate of 6. This point has got an x coordinate of 1, so now it will have an x coordinate of 2. This point has got an x coordinate of 0, so now it'll have an x coordinate of 0, twice 0 being 0. This point has got an x coordinate of minus 1, so now it will have an x coordinate of double that, minus 2. This point has got an x coordinate of minus 2, so its new x coordinate will be minus 4. And this point has got an x coordinate of 4, so its new x coordinate will be 8. So now I can simply join up my crosses to give me my new curve. Here it is. Okay, let's look at the next part of the question. The graph of y equals f of x plus k is shown on the grid below. Write down the value of k. Well, let's first of all draw the original curve, shall we? The original curve, well, it had a minimum point here, didn't it? A minimum point there, right? So, what's happened to that minimum point? It's been moved 3 units to the left, hasn't it? So if I want to move y equals f of x 3 units to the left, it's now going to be y equals f of x. Now it's going to be inside the bracket because it's a change to the x. It's going to be moving to the left 3 places, so I'm going to want to have x plus 3 there. So the value of k is 3. And that is question 4. Question 5. The point A with coordinates minus 3, 2 lies on the straight line with equation y equals f of x. Find the coordinates of the image of the point A on the straight line with these equations. Well, let's have a look at this first one. The change is outside the bracket, so it's going to be a change to the y coordinate. It's going to be a change in the direction we would expect. So I'm going to subtract 3 from the y coordinate. So the x coordinate is going to remain as it was, and the y coordinate is going to be 3 lower. Let's look at part 2. Y equals f of x over 2. Well, in this case, the change is inside the bracket, so I am expecting a change to the x coordinates, and my change is going to go the wrong way, isn't it? In here, I'm dividing by 2, so my x coordinates are going to be multiplied by 2. So instead of minus 3, I'm going to have minus 6, and the y coordinate will remain unchanged. Let's move on. Here is a sketch of part of the curve with equation y equals g of x. Okay. The point B with coordinates PQ lies on the curve. Find the coordinates of the image of the point B on the curve with that equation, where C is a constant. Right, well, let's deal with the C first, shall we? If we had y equals g of x, and that we had the point P, Q, what about if we had y equals g of x minus c? What would happen to that curve? Well, first of all, it's inside the bracket, isn't it? So it would be a change to the x-coordinate. The x-coordinate would move the way we wouldn't expect. So the x-coordinate isn't going to have c subtracted from it. It's going to have c added to it. And the y-coordinate would remain unchanged. Now let's look at the next change, shall we? Y equals minus. Right, so our function is being multiplied by minus 1, isn't it? Well, if we multiply our function by minus 1, by the way, that's happening outside the bracket, that timesing by minus 1. So it's happening outside the bracket, so it's going to affect the y-coordinate. So the x-coordinate will remain unchanged. And if we're multiplying by minus 1, we're multiplying the function by minus 1, the y-coordinate will also be multiplied by minus 1. So it won't be q anymore, it'll be minus q. So the coordinates of the point B on my new curve will be P plus C, comma, minus Q. Question 6. Now, the curve with equation y equals fx has one turning point, and the coordinates of the turning point are minus 6, minus 4. Write down the coordinates of the turning point and the curve with this equation. Well, the change is outside the bracket, so it's going to be a change to the y-coordinate in the direction we'd expect. So the x-coordinate is going to remain as it was, and the y-coordinate is going to have 5 added to it. Right, part 2. Y equals f of 3x. Well, the change is inside the bracket, so it's going to be a change to the x-coordinate in the direction we wouldn't expect. So I'm not going to multiply the x-coordinate by 3. I'm going to divide it by 3, and the y-coordinate remains unchanged. 6b. The graph of y equals g of x is shown on the grid below. On the grid, sketch the graph of y equals 2g of x. Right, well, the change is outside the bracket, so it's going to happen to the y-coordinates in the direction we'd expect. So the y-coordinates are going to double. So let's have a look at a few points, shall we? Right, the y-coordinate of this point is 1, so it'll double and become 2. The y-coordinate of this point is 3, so it'll double and become 6. The y-coordinate of this point is 0, so it'll double and remain at 0. The y-coordinate at this point will become minus 2. The y-coordinate at this point will remain at 0. The y-coordinate at this point will become 4. Y-coordinate of, well, that'll do, won't it? Right, so now I can draw my new graph by joining up my crosses, the new points. And here it is. Okay. Part C. The graph of y equals h of x intersects the x-axis at 2 points. It intersects the x-axis at minus 1, 0 here and 6, 0 here. The graph of y equals h of x plus a passes through the point with coordinates 2, 0, passes through this point. Find the 2 possible values of a. Aha, now a is all about the horizontal movement of this curve, isn't it? Because a is inside the bracket. So I suppose the curve could have done two things, couldn't it? I mean, it could be that this point was moved horizontally to the right 3 units to go through the x-axis at the point 2, 0. Or it could be that this point, the point 6, 0, was moved 4 units to the left. So there's my two possible translations of the curve, which would end up with the curve passing through 2, 0. So that's either going to be y equals h of, now let's do the first one first, moving to the right 3 units means it would be x minus 3, or it's going to be h of moving to the left 4 units, x plus 4. So my two possible values of a are going to be minus 3 and 4. And that is that question complete. Question 7. A curve S has the equation y equals f of x, where f of x equals x squared. The curve T has the equation y equals g of x, where g of x equals 2x squared minus 12x plus 13. By writing g of x in the form a lots of x minus b squared minus c, oh, that's completing the square, isn't it? So by completing the square on g of x, where a, b, and c are constants, describe fully a series of transformations that will map the curve S onto the curve T. Well, let's do what it says. And let's first of all complete the square on g of x. So g of x is 2x squared minus 12x plus 13. So to complete the square there, I'm going to take out the 2 to give me a unitary x squared. And now I'm going to complete the square on x squared minus 6x. So square bracket, x minus 3 squared minus 9, close the square bracket, copy down the plus 13. Multiply out the square bracket. Minus 18 plus 13, so I get 2 lots of x minus 3 squared minus 5. So it asks me to write g of x in the form a lots of x minus b squared minus c, and I've done that where a, b, and c are constants. So how is this going to help me describe the transformation from y equals x squared to y equals twice x minus 3 squared minus 5? Well, you can read off each of the translations now. First of all, you can see that instead of being a function of x, it's a function of x minus 3. That means that the graph has been translated 3 to the right, so it's been translated by the vector 3 to the right, so 3, 0. Then that has been multiplied by 2, hasn't it? So that's going to be a change outside of the bracket. So that's a stretch of 2 in the y direction because it's outside the bracket. And then I've got this minus 5 at the end. So that's going to be a translation. It's going to be a translation 5 down, isn't it? By the vector 0, minus 5. And those are the 3 transformations that map curve S onto the curve T. And it all revolved around looking at y equals f of x and comparing that to y equals 2 f of x minus 3 minus 5. And that is question 7 complete. Question 8. The graph of y equals a sine x plus b is drawn on the grid. find the value of A and the value of B. Well, I suppose it would be useful to draw on the graph of y equals sine x, and then we can compare the two. So here is the graph of y equals sine x, which, yes, you're just supposed to know, or of course you can use your calculator to work out some key values and hence draw the graph. Now, I see that the graph of y equals sine x stretches between -1 and 1, varies between -1 and 1, whereas my new graph has values between -2.5 and 3.5. So the range has become, it was 2, wasn't it? And now the range is 6. So the range has been multiplied by 3. So my graph's been stretched by 3. So I already know that I'm dealing with y equals 3 sine of x. Now, if I were to stretch my graph by 3, then it would look like this. That would remain there. This point would be up here. This point would remain at 0. This point would move to here. So simply y equals 3 sine x would be here. And what is the relationship between y equals 3 sine x, this red graph, and my target graph? Well, my target graph is the red graph translated by 1 in a y direction. So it is y equals 3 sine of x plus 1. So A equals 3 and B equals 1. Question 9. A curve has equation y equals f of x. The coordinates of the minimum point on the curve are -9, 15. Write down the coordinates of the minimum point on this curve. Well, the change is inside the bracket, so it's going to be a horizontal change, a change to the x coordinates the wrong way. So I go to subtract 3 from the x coordinate and leave the y coordinate unchanged. Now, part 2. The change is outside the bracket, so it's going to change the y coordinates the way that we'd expect. So the y coordinates are going to be multiplied by 1/3, divided by 3, and the x coordinate is going to remain unchanged. Gives me 9, 5. 9 part B. The graph of y equals a cos of x plus b is drawn on the grid below. Given that a is positive and b lies between 0 and 360, find the value of a and the value of b. Well, the first thing that would be useful would be to draw simply y equals cos of x. So let's draw that. Now, in answer to the question that you might be asking, yes, you're simply expected to know what this curve looks like. But of course, you can use your calculator to work out some key points to help you plot the curve. Now, let's first of all deal with the range of these curves. Now, my original curve, the blue curve, has a range from -1 to 1. It has a range of 2, doesn't it? Whereas my new curve, the black curve, ranges between -2 and 2, so it has a range of 4. So my black curve is a stretch by a factor of 2. So let's draw that curve, shall we? Let's draw it in green. Draw this curve in green. So I'm simply going to stretch the blue curve in the y direction by a factor of 2. Here it is. All right, now, how am I going to now work out the connection between the black, my target, and the green, which is where I am at the moment. How do I need to change the green to turn it into the black? Well, the answer is that I'm going to need to shift it some units to the left, aren't I? How many units to the left? Well, 90 units to the left. And if I'm going to shift it 90 units to the left, translate it by 90 units to the left, then I'm going to have to change y equals cos of x to y equals cos of x plus 90. So my value for A is 2, and my value for B is 90. And that is that question complete. Question 10. Here is a sketch of y equals a cos of x plus b. Given that b lies between 0 and 180, find the value of a and the value of b. Well, let's start off by drawing y equals cos of x. Now, y equals cos of x is this graph here. So I'm going to draw that, and now I'm going to ask myself how I could transform my blue curve into my black. Well, first of all, let's have a look at the range of my curves. Now, this blue curve has a range of 2, and the black curve has a range of 4. So the black curve is a stretch of the blue by a factor of 2. So y equals 2 cos of x is going to be a step on my way. Let's draw that red curve, shall we? So it's going to be the blue curve stretched by a factor of 2 in the y direction. Here it is. So that is my red curve. Now, how can I translate the red curve into the black curve? Well, the answer is I need to take the red curve and translate it by 3 squares to the left. So it's going to be y equals 2 cos x plus, now what's the value of those 3 squares? Each square is 45, so it's going to be x plus 135. So in answer to the question, A equals 2 and B is 135. Question 11. A curve with this equation, f of x, is transformed to a curve with this equation, g of x, but the translation a units along and b units up. Write down the value of a and b, right? Just a moment. The up, or the down, the y change, is going to be the difference between the plus 2 and the plus 8, isn't it? I can see that this curve, f of x, has had plus 6 added to it. So, just to make that clear, g of x and f of x, the first thing I notice is that g of x is f of x with a plus 6 outside the bracket. So b is 6. The curve has been moved 6 units up. Now, what else do I notice? Well, instead of being 5x squared and 9x, it's 5x plus 4 and 9x plus 4. So in fact, the g of x is equivalent to f of x plus 4 and then the plus 6. So if it's x plus 4 in the bracket, it's been moved by minus 4 in the x direction. So the value of this a here is going to be minus 4. The curve has been moved by the vector minus 4, 6. It's been moved 4 to the left and 6 up. Part B. The graph of y equals p times cos of x plus q is drawn on the grid below. given that P is positive and Q lies between 0 and 360, find the value of P and the value of Q. Well, let's start off by drawing the cos curve here, because that's obviously going to be my kind of basic curve, my starting point. So here it is. There's my cos curve. Now, how is the green curve, which is y equals cos of x, be transformed to create the black? Well, let's first of all do some thinking about the range of these curves. My original curve has a range of 2, and my new curve, my target curve, has a range from -3 to 3. It's got a range of 6. So my green curve has certainly been stretched by a factor of 3. So let's do that. Let's draw y equals 3 cos of x and see where that gets us. So I'm simply going to stretch my green curve by a factor of 3. Here it is. So here, this is y of 3 cos of x. Now, how do I move that red curve to give me the black? Well, it's simply a translation, isn't it? By 1 square to the left. Now, how many degrees is 1 square? It's 45. So my black curve is going to be y equals 3, not cos of x, but cos of x plus 45, in order to force that red curve to shift 45 units, or 1 square, to the left. So my value of P is 3, and my value of Q is 45. Question 12. The curve C has equation y equals f of x, where f of x is 9 minus 3 lots of x plus 2 squared. The point A is the maximum on point C. Write down the coordinates of A. So we want to know the maximum value of f of x when f of x is 9 minus 3 lots of x plus 2 squared. Well, that's going to be at a maximum when I'm taking away as little as possible. And how small can I make that blue expression? Because it has something squared in it, I can't make it any smaller than 0. So the best I can do is to make x minus 2, which means that the blue expression is 0, and f of x, or y, equals 9. That's as high as I will be able to get my value of f of x. So the coordinates of A are -2, 9. Now that curve C is transformed to the curve S by a translation of 4, 0. So that simply means it moves 4 to the right, doesn't it? So if y equals f of x is my starting point, and I want to move that 4 to the right, I'm now going to be dealing with y equals f of x minus 4. So instead of being 9 minus 3 lots of x plus 2 squared, it's now going to be 9 minus 3 lots of x minus 4 plus 2 squared. And if I wanted to simplify that, I would have 9 minus 3 lots of x minus 2 squared. That is parts A and B done. Part C. The curve C is transformed to the curve T, and the curve T has that equation. Let's just compare my two curves. I've already copied down the equation of the curve C. So the curve T is y equals 3 lots of x plus 2 squared minus 9. And the question really is, how do I transform this blue expression to give me the yellow expression? Well, if curve C is written as y equals f of x, then curve T, well, I see that the plus 9 in curve C is changed to minus 9, and the minus 3 lots of the bracket has changed to plus 3 lots of the bracket. So if the curve C is written as y equals f of x, the curve T will be y equals minus f of x, or y equals minus 1 times f of x. So what's that transformation going to be? Well, it's a transformation it's a change to the y's, isn't it? And we're multiplying the y coordinates by minus 1. So if this had been the curve, doesn't really matter what it had been, but if that had been the curve, then the new curve would look like that, because each of the y coordinates would be multiplied by minus 1. So what is that? It's a reflection in the x-axis. The graph of y equals a times cos of x minus b plus c is drawn on the grid below. Find the value of a, the value of b, and the value of c. Right, let's start by drawing our cos curve. It's through here, and here, and here, and here, and here, and here, and here. Right, so here is my standard cosine curve. Y equals cos of x. And let's transform that graph bit by bit, step by step, so that we end up with the black curve. First of all, let's look at the range of these curves. I mean, my blue curve has a range of 2. My black curve, well, that range is from here to here, from 5 to minus 1. So that's got a range of 6. So I'm dealing with a vertical stretch of 3 in the y direction. So the first thing I'm going to be looking at is y equals 3 cos of x. So let's transform our blue curve to give us y equals 3 cos of x. I'm going to stretch the blue curve by a factor of 3 in the y direction. Of course, not all the points will fit on, but here it is. It's going to look like this. And up it comes to there. So that green curve there is y equals 3 cos of x. Let's get rid of the blue. Okay. Now I need to continue my transformations. I need to continue. So I'm going to think, what do I need to do to that green to make it more like the black? Well, it's the same shape now. It just needs translating. It's going to need translating 2 units up, isn't it? I'll change to a blue pen. It's going to need translating 2 units up. Okay. So let's translate that curve 2 units up. So I'm now going to have y equals 3 cos of x plus 2. Right, and now the curve that I'm dealing with looks like this blue one here. Okay, that's 2 units up, that's 2 units up, this one's 2 units up. So here it goes like this. There it is. Okay, something like that. All right, good. Now, there we are. Okay, now what's my final movement going to be? Okay, what's my final movement going to be? It's going to be a translation by 90 units to the left in order to give me the black curve. So I'm going to have y equals 3 lots of cos. Now, what shall I do inside this bracket? I want to go 90 to the left, so I'm going to write x plus 90 plus 2. So my value of a is 3. The value of b, do you notice how it says minus b here? So my value of b is going to be minus 90, and my value of c is going to be 2. Right, well done. That's your lot. Thanks very much for watching. I hope you found the film useful. If you've got a question, leave it in the comments and of course I'll respond. Or tell me in the comments how you got on with the film and what you are focusing on next as you prepare for your Edexcel IGCSE Maths. Thanks for watching. See you in the next film.